Egypt's Great Pyramid of Giza, one of the wonders of the ancient world, and a dazzling feat of architectural genius, contains a hidden void at least 100 feet long, scientists announced on Thursday. The space's dimensions resemble those of the pyramid's Grand Gallery, the 153-foot-long, 26-foot-tall corridor that leads to the burial chamber of Khufu, the pharaoh for whom the pyramid was built. However, it remains unclear what lies within the space, what purpose it served, or if it's one or multiple spaces. The void is the first large inner structure discovered within the 4,500-year-old pyramid since the 1800s, a find made possible by recent advances in high-energy particle physics. The results were published in the journal Nature. This is definitely the discovery of the century, says archaeologist and Egyptologist Yuka Norikawa, a National Geographic emerging explorer. There have been many hypotheses about the pyramid, but no one even imagined that such a big void is located above the Grand Gallery. Built to last. The findings mark the latest in a millennia-long quest to understand the Great Pyramid of Giza, long an object of mystery and intrigue. The pyramid was built some 4,500 years ago during the 4th dynasty of ancient Egypt's Old Kingdom. At that time, Egypt was a powerful, highly centralized monarchy, wealthy from trade and Nile-nourished agriculture. The Great Pyramid is arguably the ultimate expression of that power. The pharaoh Khufu, who reigned from 2509 to 2483 BC, built for himself a pyramid whose base spreads across more than 13 acres and originally towered 479 feet tall. The monument consists of about 2.3 million limestone blocks, which had to be quarried, transported, cut to size, and moved into place. Read more about the extraordinary pyramids of Giza. These sorts of pyramids are the major product, so to speak, of the kings who built them, says Kate Spence, a University of Cambridge archaeologist who studies ancient Egypt. An awful lot of Egyptian society is probably geared toward building pyramids at this particular time. Ever since, the Great Pyramid has drawn in the curious. Today, tourists enter the pyramid through a tunnel created in the 9th century AD. The National Geographic Society has helped conduct 2 explorations of the pyramid, including a 2002 exploration of the air shafts extending out one of the pyramid's 3 chambers. Seeing the invisible. The new discovery comes out of the Scan Pyramids Project, an international mission under the authority of Egypt's Ministry of Antiquities. Launched in October 2015, the project aims to non-invasively peer into Egypt's largest pyramids using a battery of technologies. Previously, Scan Pyramids had announced the detection of some intriguing voids and anomalies, which didn't come necessarily as a surprise. Spence says that the pyramid's interiors are far more pockmarked and rubbly than people usually imagine. But the new void definitely came as a surprise, and arguably marks the biggest ever discovery yielded by muon radiography, an imaging technique first demonstrated in Giza's pyramids. It's a striking discovery, says Chris Morris, a physicist at Los Alamos National Laboratory and expert on muon imaging techniques. This makes another muon radiographer jealous. I'm jealous. These guys have discovered a remarkable thing. The technique, which has been used to peer through cathedral walls, Mayan pyramids, and even volcanoes, relies on the natural drizzle of subatomic particles called muons. These particles shower Earth all the time, flung off when cosmic rays, high-energy particles racing through our galaxy, collide with Earth's upper atmosphere. If you're reading this story on your smartphone, 6 muons will have harmlessly passed through this screen by the time you finish this sentence. While we can't see muons with the naked eye, scientists can spot them with special films and detectors that trace their 3D paths. Since muons pass more easily through empty space than through solid materials, arranging multiple muon detectors in and around a structure lets scientists map the structure's solid and empty parts. What's so delightful is that muons are like Goldilocks. They lose enough energy to detect them, but not so much that they just get absorbed in the target, says University of Texas at Austin particle physicist Roy Schwitters, who uses muons to study Belize's Mayan pyramids. They're really a fabulous treat from nature. In the Great Pyramid's case, a team led by Nagoya University physicist Kunihiro Morishima placed muon detectors inside the pyramid starting in December 2015, letting them collect data for months. Morishima's first results came in March 2016, and to researchers' surprise, they suggested that a region deep in the pyramid's interior let many more muons through than they had been expecting. These excess muons seem to trace a 100-foot-long cavity with a cross-section resembling the Grand Gallery. 2 additional teams from Keck, a Japanese particle physics research group, and CEA, France's Atomic Energy Commission, worked from August 2016 to July 2017 to confirm Morishima's work. Each team used a different method for spotting muons. In each experiment, the researchers saw a signal for the void that achieved at least a 5 sigma level of statistical significance, which means that there's less than a 1 in a million chance that any one experiment was a fluke. This same level of evidence is required when discovering new subatomic particles like the Higgs boson. Big void, bigger questions. The seemingly empty region, which the researchers neutrally call the void, is at least 100 feet long. Its purpose remains unclear. Researchers are cautiously avoiding the word chamber for the time being. We don't know for the moment if it's horizontal or inclined, or if it is made from one structure or several successive structures, said study co-author Mehdi Tayyoubi, president and co-founder of the Heritage Innovation Presentation (HIP) Institute, in a press briefing. What we do know is that this void is there, that it is impressive, and that it was not expected by any kind of theory. Tayyoubi and his colleagues stress that they don't know what the void is, but already, Egyptologists have some initial ideas for what it might be. Spence, the Cambridge archaeologist, says that the void may be a leftover from the Great Pyramid's construction. She points out that massive blocks weighing tens of tons form the roof of the chambers above the King's Chamber, the central room where Khufu was laid to rest. Since the void aligns with the Great Pyramid's upper chambers, which were put there to relieve pressure on the King's Chamber below, Spence suggests that the void may have been an internal ramp used to move the massive roof blocks into place. As construction continued, she says, this ramp could have been left empty or loosely backfilled. It's the position of the void that to me makes this interpretation the most likely, says Spence. It's too well placed for getting blocks into place up there. Salima Ikram, an Egyptologist at the American University in Cairo, says that the void's location directly above the Grand Gallery might imply its involvement in that corridor's construction. That said, she wryly suggests taking current interpretations with a grain of salt. I don't think it's ever too early to speculate, but you might be widely wrong, she says. Time will tell whether these or other ideas about the void's purpose pan out. Tayyoubi and other Scan Pyramids collaborators say that work is only beginning. And to those fantasizing about personally exploring the void, a word of caution. No known corridors connect to the space, and researchers and outside experts alike stress that there are no future plans to drill into the void. Instead, they say that in the near term, they will do whatever they can to peer into the space non-invasively. There's lots of heavy, thick rock, and by drilling something, you don't know how you will affect the entire thing, says Ikram. If there's something behind the Mona Lisa, would you want to wipe her clean and see what's behind her? You really have to preserve the integrity of the monument.